Hey guys, today we're going to talk about trapezoids. There's actually not a whole lot to trapezoids. What makes trapezoids? What makes a trapezoid is that it has a pair of parallel sides, just one, and because of that, these two sides are parallel, which means this is a transversal. So that means these are same side interior angles. So this angle, let's call it, well, let's start here. This is also transversal. These are same side interior. Let's number them 1, 2, 3, and 4. Angle 1 plus angle 2 is going to be 180. Angle 3 plus angle 4 is going to be 180. And that's it. No sides are the same length. No angles are congruent. If it's a regular old trapezoid, that's all we know. Over here with the diagonals, we can draw the diagonals like this. But except for the fact that this angle would be the same as this angle, and this angle has to be the same as this angle, we don't know anything else. That's all there is. These angles have to be the same because they would be alternate interior angles at that point, but that's it. We don't know anything else. These aren't the same, these aren't the same, these aren't the same. They don't add up to be, this and this don't add up to be anything in particular, and neither do this one and that one. That's it. This is it for a regular trapezoid. So if it says here that QRST is a trapezoid and QR is parallel to ST, that means there's two ways we could set this up. Okay, so if I draw a trapezoid, and QR is parallel to ST, I either have to make this QR or this QR, because ST has to be the one that's parallel to it. So I'm just going to go QR. Now, I don't put ST. Remember, you still have to go around, so QRST. Angle Q is 47, and angle S is 104. What are the measures of R and T? Well, remember that these two add up to be 180. So 180, for T, 180 minus 47 is 133. And these two add up to be 180. So 180 minus 104 is 76. That's how you would do that if you had just a trapezoid. Now, if you have an isosceles trapezoid, now there's a lot of stuff we can say about an isosceles trapezoid. All right, just like before, that angle or that side is parallel to that side. With an isosceles trapezoid, this side is the same as this side. Also, this angle is the same as this angle. This angle is the same as this angle. And again, 1, 2, 3, 4. Angle 1 plus angle 2 equals 180. Angle 3 plus angle 4 equals 180. We could also say that since 2 and 3 are the same thing, we can say angle 1 plus angle 3 equals 180. And since, since 1 and 4 are the same thing, we can say angle 2 plus angle 4 equals 180. Lots of stuff to say about an isosceles. Over here with the diagonals, there's stuff to say too. With the diagonals, here's the deal. Lots of angles the same, lots of parts the same, not a 90-degree angle or anything in the middle, but this segment and this segment are the same, this segment and this segment will be the same. This angle is the same as this angle, which is the same as this angle and that angle. And this angle is the same as this angle. And this angle, 2, 3, is the same as this angle. 1, 2, 3. So lots of stuff is the same on this one. Okay, so let's try these problems. It's a little bit tougher this time. ABCD is an isosceles trapezoid. Segment AD is parallel to BC. So again, you draw a trapezoid, this time an isosceles trapezoid, if you can. AD is parallel to BC. So AD, and BC needs to go on the top. And it's ABCD, so I go ABCD. Angle B is 5x minus 37. Angle A is 9y plus 18. Angle C is 4x plus 17. There is no question. I don't know what the question was going to be here. Let's see. Let's make a question. Can't believe I didn't write a question to that. Let's say, I remember what it was going to be. It was going to be find the value of y. That's what it was going to be. My apologies. So, I got x here and x here. These two angles are the same. I got a y down here. I can't mess with that right now. So these two things have to be the same, so I'm going to say that 5x minus 37 equals 4x plus 17. If I subtract 4x on both sides, I would then get that this side is just x minus 37, and this side would just be 17. Then I would add 37 to both sides, and x would be 54. So x is 54. If I plug that in here or here, ooh, that's not going to work. Ooh, I should have worked that out before I started, because that's just not going to work. Because, bad. Guys, I apologize. This is not going to work, because when I plug this in, this angle is going to be 200 and something. Well, when I plug it in here, this one will be 200 and something. And that means that altogether right now, that's 400 and something. That's not going to work. So, you know what? Honestly, I'm just going to tell you to skip this equation. I apologize. I wrote a bad problem and I didn't check it. Hopefully I didn't screw up on this one. Let's see. Oh, it's segments. I couldn't have messed that up. All right, so again, we got an isosceles trapezoid. QRST is an isosceles trapezoid whose diagonals intersect at point P. Segment QR is parallel with ST. So I'm going to put ST here. QRST. So Q would have to go here. QRST. Whose diagonals intersect at P. All right. Segment at QP. So this part is 5x. Segment TP is 6x plus 8. And segment PS is 4x minus 12. 4x minus 12. Well, what we know, and we want to know how long this is. What we know is that these two segments are the same. So 6x plus 8 equals 4x minus 12. Thank goodness. That's plus 12. I was going to say, I messed this one up too, but I didn't. Okay. So, to solve this, I would subtract 4x on both sides. So this will be 2x plus 8, and this will be 12. And then I'm going to subtract 8 on both sides, so 2x would be 4. So x is going to be 2, because I would divide that by 2. Now that I know x is 2, I can plug it in and find out how long tr is, because SQ and tr are the same length. So if I plugged in 2 here, 5 times 2 would be 10. If I plugged in 2 here, 4 times 2 is 8, plus 12 would be 20, and that means the whole thing is 30. Again, I apologize for that second example, guys. I didn't mean for it to work out that way, but it did. I'll try to have a good one like that for us to do as a warm-up sometime next week. That's it.